Now we're going over the guided practice for parallelograms. So we're on looking for JK. JK is this side, and that side is parallel with LM. So we can set those two equal to each other. 7x equals 3x plus 14. Subtract 3x from both sides. So we have 4x equaling 14. Divide by 4 on both sides. So we have x equaling 7/2. But we need to find JK, so we need to substitute that 7/2. So 7 times 7/2. So when we multiply 7 times 7/2, we get 49/2. So that's the length of JK. That also means that it is the length of LM. So LM is also 49/2. Then next up, we are looking for the measure of angle L. So we've got angle L, and we have information about angle M as well. And we know that these are same side interior angles, which means that they are supplementary. So we can add these two together and set it to equal to 180 degrees and solve for Z that way. So we have 5z minus 6 plus 2z minus 3 equaling 180. Combine our like terms. That gets us 7z minus 9 equaling 180. We're going to add 9 to both sides. We have 7z equaling 189. And 189 divided by 7 is 27. So z equals 27. Now we need to go and substitute it in for angle L. So 2 times 27 minus 3. We get 51 degrees. And then again, we've already solved for z. We need to find the measure of angle M, so we need to substitute 5 times 27 minus 6. So 5 times 27 minus 6, we get 129 degrees. Our next set, we want to determine if each quadrilateral must be a parallelogram and justify your answer. So on this first one, we know that we have opposite angles that are congruent. So that is one of our properties that tells us that we have a parallelogram. So yes, this is a parallelogram because opposite angles are congruent. Number 6, we have one set of opposite sides congruent and one diagonal that's getting bisected. So diagonals being bisected is a thing, but we only have one diagonal being bisected. Opposite sides being congruent is another reason why these would be a parallelogram, but we only have one set of opposite sides being congruent. So this is not a parallelogram, and you can either put, because we only have one set of opposite sides congruent, or we have only one diagonal being bisected. Number 7, we have one set of opposite sides that are congruent, and we have a set of angles that are congruent. Now, these are not opposite angles that are congruent. They are, however, alternate interior angles that are congruent. And remember, when you have alternate interior angles that are congruent, you have a set of sides that are parallel. And this side are parallel. So that set of sides is both parallel and congruent. And that's one of our properties, is that one set of opposite sides is both parallel and congruent. And our last example on the guided practice, we want to find the values of A and B that would make the quadrilateral a parallelogram. So we have 3 things that have A in it and 1 that has a B. So we're going to deal with A first. And we have opposite sides that are congruent. So 2A plus 6 equals 3A minus 10. And we're going to solve for A. Subtract 2A from both sides and add 10 to both sides. So we have 16 equaling A. So we've got A now. That means we can plug it in to our third side that has A. So 5 times 16 plus 1 is 81. Now we have opposite sides that we can deal with. So 6B minus 3 equals 81. We're going to add 3 to both sides. And 6B equals 84. We're going to divide by 6 on both sides. So we have 14.